group of AEC OO professionals who have been gathering since 2007 to network, share best practices with regards to building information modeling, and in so doing, help advance the industry. Today, we are joined by an international speaker, Dion, who is the lead developer of Blender Bim, an add-on to Blender. Um, you probably read his blurb. I just want to mention that beyond that, my personal impression of this project is that out of the box, it's quite exciting. It supports things like IFC, Kobe, out of the box, unlike Autodesk, where you have to install an add-in and then it ships with the wrong version of OmniClass, only one of the tables. It's quite exciting. But anyways, Dion will be speaking on open source, open data, how it can help transform our industry. And please note, well, I mean, being such an early project, it's quite exciting that it's under a year old, yet it's able to support things like fabrication and even some rudimentary forms of producing documentation in 2D. So please note that this session will be recorded. It's our first time using Google Meet, so please be understanding should anything go wrong. Please mute yourselves, and we will allow some time for questions near the end. But we'll leave it up to Dion if he wants to take them as they happen. So Dion, thank you again for joining us. I'll let you take it from here.
Hello. Thanks very much, Edwin. Hopefully you can all hear me.
Yes.
If not, I guess you should. Okay, that's good. And I'll press the present now button. And if it sounds as though I've just woken up, that's because it's 5 a.m. here. I'm speaking from Sydney, Australia. So hopefully I'll be a little bit coherent today. So today I'll be talking a little bit about open source and open data and what it means for the built environment. And I guess I'll start with a bit of an introduction. My name is Dion Molt, and I was trained as an architect and also worked in an architectural role in an architecture firm for quite some time. But I also have a background in software development and in volunteering in open source initiatives. And this has been going on for a long time, over 10 years. And here's a small selection of some of the projects that I've been involved with. From the computer operating system that I use, which is Gentoo Linux, the interface that I use, Blender, of course. Many of you might have heard of Blender, which is a very famous 3D content creation suite. It's used a lot in the CG industry, perhaps a little bit less in the construction industry, architecture and engineering industry. Then there's Radiance, which is seen as the sort of gold standard for lighting simulation. And also OpenStreetMaps, you might have heard of, which is a fantastic initiative to provide an open source editable version of Google Maps. But I think I'd like to start a bit with what is open source, because you'll notice on the previous slide I called it free software, and here I'm talking about open source, and that's largely because they are one and the same, or at least they used to be one and the same. Then the ideal sort of diverged a little bit. So originally, all software was free software. And it's only nowadays that the norm has shifted, and we're used to proprietary software being normal. But originally, the majority of software was free. And when I say free, I'm not talking about price. I'm talking about the freedom that it gives you as a user. So when we talk about free software open source, it's not about somebody volunteering their time and just giving it away for free. It's about an initiative to give users software that they can do anything they want, whether they want to learn from it and read the code underneath to find out as a super user how exactly it works, or whether they want to fix it if something goes wrong, or if you're a large company, you want to tailor your own digital pipeline. That's where free software lets you do these things. Or if you want to push the boundaries in academia, or if you're just a type of person, that's what free software is about. It's not about the cost, it's about the freedom it gives you as a user. So it's all about what you want to do with the software. And one of the prerequisites for being free software is that the source code of that software needs to be provided to the user. Because without that source code, you can never have that greater level of flexibility. And so that's where the term open source came from. It was a term which came after free software, and was, unfortunately, in our industry, is not that common. But in other industries, the concept of free software and open source is not just common. In fact, the industry can't survive without it. So, for example, the technology industry. You cannot write software nowadays without relying on open source. It's almost impossible. The way the internet works functions on open source software, or I should say, free software. And the CG industry is also beginning their migration towards free software. And that's because when you have free software, it's not powered by a company, it's powered by a community. And so it never really dies. People sort of work on it because they have so much flexibility, and they continue to work on it and improve it over time until it becomes more and more powerful. And there's nothing which can really cause it to fade away. Lots of free software is very old, and over time it becomes just as powerful, if not more powerful, due to the decades of investment in it compared to proprietary software, and an industry tends to become dependent on it. Now, this hasn't happened yet in the AEC industry, but it's something that probably will happen. But at the current state of things, we're still in very early days for free software in AEC, and I must say it's quite exciting. So I talked a little bit about open data as well, and you can't mention one without the other. So the free software refers to the tools that we use, the tools that we are free to do whatever we want with, unhindered by being tied to another company to tell us what we can and cannot do. But it only works if you also have open data. So open data is the concept that the information that our tools ingest and analyze and spit out are part of a freely published specification. Because if that specification of the information is kept private, then it's not possible to allow our software to speak to one another. And this is something that's normal. We consider normal right now in the industry. We expect not to be able to open one proprietary format with our BIM authoring program with another proprietary BIM program. We expect not for our environmental analysis tool or structural analysis tool to speak to our costing tool, for example. Our tools are siloed due to the fact that our data is, I guess you would call it, closed data. And again, just like open source, open data is actually normal in other industries. Again, the biggest example being the software industry. The reason the internet works, the reason why you can have 5 web browsers who all view the same web page, is because the data, in this case, the HTML and JavaScript, which describes how a website's meant to look, is what's called open data. And open data does exist in the AEC industry. Some of you might have heard of it. It's called things like IFC, Industry Foundation Classes, which is an ISO standard of how to store our BIM data, developed by Building Smart. And there's also initiatives like BCF, which allow you to collaborate on issue management, for example. And now we're seeing an initiative about open CDEs so that your CDE can also talk from one to another, and your business data is not locked into a single CDE provider. So hopefully that introduction made a bit of sense. But I think the reason why I was asked to give this presentation today is because of this piece of software here. So this is a screenshot of Blender, and Blender is a 3D authoring program, and it does everything from 3D modeling, rigging, animation, texturing, sculpting, rendering, VR. It's got plugins for AR and construction lines and visual programming and non-visual programming and NPR rendering, and the list goes on. Blender has quite a big ecosystem around it. And just under a year now, I have been working on an add-on to Blender called, very unimaginatively, the Blender Bim Add-on, which does exactly what it says on the box. It tries to add BIM functionality to Blender. So Blender out of the box is designed for the CG industry, which has a very different set of use cases to the AEC industry, which for better or for worse. And I guess you could think about its scope as similar to SketchUp, even though it does a lot more, in that it's primarily to do with geometry and much less to do with metadata. Whereas in the BIM industry, we are concerned not just with the geometry of the object. In fact, our geometry is usually pretty rudimentary and basic, just some boxes, for example. And it's the data, which is really useful to produce schedules and put in orders for fabrication and to do costing and timelining for construction sequencing and so on and so forth. So the purpose of Blender BIM was to add these types of BIM functionality to Blender. And it does that by implementing the Open BIM ISO standard that are provided by Building Smart, one of which is IFC. So as was introduced in the beginning, Blender does Blender with the addition of this add-on is capable of reading an IFC and writing an IFC. And along with reading and writing, you can natively author a BIM model with it. So here you can see, this is a very small example of just a set of steel stairs. And this is a side-on view. And you can add metadata and spatial structure to those stairs and add attributes and properties and so on. And these attributes and properties are also designed in such a way to comply with OpenBIM specifications so that the data you get out is extremely structured and clean. And it's also a little bit different to other BIM applications because it uses IFC sort of as a native data schema. And what I mean by that is that most BIM applications have two ways of thinking about your model. The first way is the native way in which you model. So if you model with Revit, for example, you know all of Revit's quirks, and you have to model in a particular way to satisfy Revit and classify your objects in a particular way. And then when you export to IFC, a translation happens. So it translates it from the way Revit thinks about it to the way that the ISO standard thinks about it. And during that translation, due to a variety of factors, there is inherently quite a bit of information loss. And I think part of that is what's given these initiatives for interoperability such a bad name, because we sort of expect to receive an IFC, ingest it, expect half the data to be lost, and export an IFC, and then expect another half of the data to be lost. So it kind of defeats the purpose of interoperability if there's so much data loss. And that's due to that translation. Whereas Blender Bim is designed right from the start to be optimized for this ISO standard. So the amount of data loss is relatively small and is decreasing with each release. Unfortunately, that brings me to another point that I believe IFC is actually not that well known still in many parts of the world and the industry in general. I mean, you might have heard of it, but many people haven't actually dug down into their BIM files and try to see how their data is structured. And this is quite important because if you look at the progression of how we're dealing with our data, we move from paper drawings where all our information is on a physical sheet of paper, and then we say, oh, this will be much more convenient if we had it in a digital form. So I guess the next step up is putting it in a spreadsheet software. So if you put all your schedules in a spreadsheet software, and now you have new tools and ways of slicing and dicing your data, like filtering and searching and VLOOKUPs and things like that. And you say, oh, this is a lot more powerful. And then the next step up from that, I guess, is where we are right now. We have geometry, and then instead of an Excel spreadsheet, we have a proprietary database, which is a step up, certainly, from an Excel spreadsheet in some ways. But it doesn't change the fact that our data is inherently unstructured and unstandardized. So to make the next leap towards programs that are able to interoperate with each other, which is, I hope, what we're all aiming for in the AEC industry, we should be pushing not just for a database, but for an ISO compliant, standardized, highly structured database. And right now, the biggest contender for that we have in our industry is IFC. And so what I hope to do today is first to introduce a little bit about this Blender Bim add-on, but more importantly, because the add-on will change and come and go, but much more importantly, to introduce what's actually possible if the industry tried to work together a bit. If we stop thinking in terms of monopolies and stop thinking in terms of tools, and just as I put at the beginning of the presentation, we start thinking about purpose instead. What do we want to do? And then let's just build the tools for that purpose and forget about being tied down by what a seller tells you can and cannot do. What's the purpose? So, for example, on this screen, you see some stairs, but you also see a point cloud. And this is a scan of the building site in construction. And for example, did you know that you can actually store a point cloud in an IFC file? And the functionality is there. I don't think many people have actually done this in their software, but the functionality is there. And in fact, there is a currently work in progress initiative to take these point clouds, and not just point clouds, but other big data sets of IFC, and compress it to a highly efficient binary form. So as you know, IFC has many formats it can take, one of which is a .ifc file, which is plain text, but it can also be represented in other ways to integrate with other technology ecosystems. And one of the ways we're sort of pushing the boundaries here of what's possible for the purposes of building validation once it's been constructed, and data archival for newly constructed buildings and heritage buildings, is to allow you to store semantic structured point clouds, which relate back to individual building elements in IFC form. Now, another example I'd like to show is this photo here. So this is my living room in a place that I lived in a year ago. I've since moved house. Now, this is a very interesting image. And the reason I say that is because it's not a photo. This image you see is actually a render. And there's two things which are special about this render. The first thing is that it's a BIM model. So what you see here is not something which is handed off to a CG artist and was later produced and handed back, but this is actually a render taken directly from an IFC model. And it's got all the details right down to the sort of folded cloth in the bottom left, to the blades of grass outside, to the each individual photo scanned leaf on the right hand side, and the sockets and switches and little keyholes and so on and so forth. And this is all stored directly in a BIM model. And when coming from the CG industry, this is every day. This is what you expect to see in a model. Coming from the BIM world, this would be seen as overkill. Why are you wasting your time? But that's largely due to the mismatch in the modeling capabilities of BIM programs versus the modeling capabilities in CG software. But the fact that this is a BIM model, and not just any BIM model, it's an ISO compliant IFC model, is just half the story. The other half of the story is that this is actually not a regular render. This is not a render that might be produced by a CG artist. This is a render produced by Radiance. And the data is taken from photometrically correct, physically measured materials of every single object in this room. So, for example, one of the things is that we have to do certain lighting studies of our designs for legislative requirements, or even just to test aesthetically what it might look like. And there are certain physical properties of materials which you need to store. And so this BIM model was modeled as pure geometry, and then all of the material and light data was measured with physical devices, and a text, essentially a big text definition of metadata was assigned to these BIM objects to define their lighting and material properties. There was not once was a color picker used. There was no changing around lights and doing test renders, none of that. This is the very first render out of the box describing real physical properties of light and material, straight from a BIM model, which has then been able to be fed into a validated, photometrically accurate lighting simulation software, such as Radiance, to then produce this image. So most lighting simulation deals with things like illuminance and certain quantitative types of analysis. So you don't often see lighting simulation produce images like this, but the engines are certainly capable. So if you flip it on its side and say, I want to create a luminance simulation of what a room might look like, it's actually possible to do this. And you can sort of see in this next slide the resemblance to real life. So on the left, you have the rendered image taken again directly from the BIM model at different times of day at different lights being on and off. And so on the top, we have the nighttime condition. And on the right, we have the actual photo. And you can see that about halfway of modeling things, they got a little bit bored and decided to do something else, because you can see how messy the room is. But what this shows is that if you really wanted to push the boundaries, free software does give you that flexibility. Radiance is also another piece of free software, very, very old free software. And unlike other rendering engines where the data might expire after a few years, or I guess even in BIM modeling packages, all of your BIM data, which you've invested so hard in, tends to expire after a few years, at least in the old days. And CAD drawings, they persisted a little bit longer than that. This simulation will persist because it's all plain text, it's all based on open standards. So many, many years from now, people will be able to recreate this exact setup. And that's perhaps another demonstration of something you can do with OpenBIM and purely open source software. I should probably mention that this was also in part developed with Blender Bim. And this is another image which you might have seen floating around. This is something that some people don't realize. It's still in the early works, but Blender is capable of producing construction documentation. But again, I should preface that with the fact that it's very early works. But more specifically, this construction documentation is not the way that you produce it like out of Revit or ArchiCAD or Tekla or so on. This is produced from an IFC file. And an IFC file can actually store 2D plans and sections and views and all the rest of it. People don't use this functionality, again, because the vendors have not implemented it. But it is part of the ISO standard. And if we had a little bit, I guess as users, if we thought this was important, maybe this is something we should pursue. I mean, we all, I hope, in the call recognize the importance of open BIM standards, but the BIM model is just half the story. A BIM model will never be enough. You always need a set of documentation to help describe the BIM model to people who are viewing it, like a map, a sense of directions or diagrams to direct them to areas of interest and importance. And what form that takes will probably change in the future as we move towards more AR-style technologies and people having tablets on site and being able to query things on the fly. But the fact still remains that it's extremely important to have, as part of our legal contract, a delivery of an instruction set of how to interpret the BIM model. And it's a bit surprising that we have ISO standards for the BIM model, but we don't really, but people haven't really said, okay, what about the other half of the information, which is, I guess, the drawings. So the Blender Bim has still bare bones, but as you can see, we can produce certain types of output with it. And we have produced output to the extent of right down to fabrication level drawings directly in Blender, again, from the IFC file of a door. You can see here how that tag actually relates back to an IFC space. And in this case, it's extracting 3 pieces of information from that IFC space, and so on and so forth. But more than that, this little demonstration, the BIM model is open. It's an IFC form. The software is open source, but the documentation is also open. The documentation is stored in IFC, but it's extracted out in SVG format. So this takes a departure from proprietary formats like DWG or DXF, because SVG is an open standard for displaying vector information. So why can't we use it in our documentation? Why must we rely on very old or closed data formats like DWG and DXF if there is a modern vector standard which is supported in every single browser? So immediately anybody can view this. Anybody who has a browser, even on their mobile phone, can view this. And not only can they view it, this is essentially a web document. You can put links in an SVG. You can hyperlink people in your plans and sections. You can use CSS. If some of you have done some web design before, you might know that CSS defines the style of the website. So your floor plans can have things turned on and turned off and colors changed on the fly by your viewing application. And that's not just a gimmick. It means that one floor plan could essentially have many layers of information embedded on it, which is toggled on and off, and linked to one another. And that sort of gives a glimpse of how documentation might turn into the future, where you don't where everybody on site or in meeting rooms has interactive screens. So we no longer really need to spend hours sort of shuffling tags around to make sure they don't overlap, maybe. And maybe that in itself is reason enough to pursue this sort of new way of looking at things. But again, this is about the purpose first. And with the freedom, instead of being told what you can and can't do by a vendor, of open source, this, again, is another demonstration of something you might be able to achieve. This is another small demo, just a quick one. This is I think this is Sydney. These are 3D buildings, just a very rudimentary form, taken from OpenStreetMaps. So OpenStreetMaps, another really excellent initiative, lets you draw building footprints. So why not? Every time you do a site plan or initial site survey, why not you contribute those back to this open source initiative? All that time spent wasting by tracing roads and buildings at early feasibility stage, and it's just not necessary. Or when doing urban scale diagrams, it's this OpenStreetMaps data set, unlike Google Maps, is something you can download. So some of you might know this already, but OpenStreetMaps is vector. So, and you can download the database and interpret the data how you'd like. So I can actually run a data query, and actually I did so last week, saying, hey, OpenStreetMaps, please find me all outdoor basketball courts within a certain radius of my house that is open to public access. And because all that metadata is in there, you can query it and you can use it for whatever types of analysis you'd like to do. And in this case, I said, okay, OpenStreetMap, fetch me all the building footprints which have height data and extrude it into a 3D form. And then this city model was then converted into an IFC. Because in an IFC file, you can actually store many, many buildings and many, many, many plots of sites. And that will become more and more common in the future as we move towards not just vertical BIM projects, but more horizontal BIM projects, and a merge of the two into a sort of digital twin of entire cities. And that's something that's just not quite possible with closed data formats or closed repositories like Google Maps. So it's something I would advise investigating a bit further. Again, this was done with OpenStreetMaps and the Blender Bim Add-On as well. This is another interesting little demonstration. It's still very simple right now. This is I have to give credit to Ioannis, who helped build this integration. Ioannis is trained as a structural engineer, so he can do things with numbers that the rest of us cannot. And this is a single beam being analyzed in open source software called CodeAster. But the beam actually comes from an IFC file. And some people don't know this, but IFCs can store structural analysis models. And it can store structural curve members and point connections and loads, and store the results of the structural simulation back in the IFC model. So you no longer have this disconnect of a separate model with a separate dead tree report that describes what's going on, which then has its own life compared to the models of the other disciplines. And I think that's what we've been trending to anyway, is the fact that our models are interconnected between the disciplines, because the building design is interconnected. It's all about the relationships between the disciplines. And so the ability to integrate our data in this way is something we should aspire to. As you can see, it's still fairly early days. There are some other a bit more impressive models than a single beam, but this demonstrates the concept. I think IONIS has also released the only web-based structural analysis viewer for IFC, which is a really, really fascinating project to investigate. Oh, I should mention that Codester is also open source. On the left, Codester, I think, is the simulation package for structural simulation. Salome, Mecca, I believe, is a sort of interface for it. I could have got this wrong. I'm not the expert in this. And on the right is ParaView, which lets you view the results in various ways of the simulation. And over here we see, I guess this is just a building being cut away in a particular way. There's certain types of ways we can slice and dice the data. And nowadays, these are already common in other software, like the ability to create sections on the fly in real time, or include or exclude objects, or color code objects by attributes or properties and all that. Blender Bim does have those functionalities. The add-on was written with the expectation that a lot of people would be using it not as a native authoring tool, but that some people would use it simply as a way to interrogate the data. So these functions do exist. It's probably not too much to talk about. This one's a bit interesting. The Blender Bim add-on also supports BCF. And BCF stands for the BIM collaboration format, as you can see here. And so every time you do issue tracking, this is a standardized way to store information about the issue. Things like the status, the priority, the discipline, as well as certain viewpoints. And then if you scroll down here, which is not shown in the screenshot, it's got a whole bunch of other metadata and comments. So the ability for somebody to view your issues in one program versus another is made possible by things like BCF. And Blender Bim is, I think, one of the few which implements the specification in full. So there are some neat little tricks you can do, like on-screen drawing and text on the screen, and also bitmap overlays in issue management. Other software might have that functionality natively, but they don't necessarily store that in the BCF, which means that it's lost once you bring it somewhere else. And that should be ringing some alarm bells, because this is part of our, I guess, sort of legal evidence of the sort of coordination that was done. So if there was ever an issue, it's important that this information is retained. Clash detection is another quite important feature. Blender Bim add-on has implemented clash detection, and it does kind of what you expect from clash detection. You know, you can specify clash sets. You say, I want set A to clash with itself, or set A to clash with set B, and set A can come from a variety of models. It can be one ISC file, it can be 10 ISC files, or it doesn't matter. And it can be all objects or just a subset of objects. So this has a certain tolerance. There's nothing really special here. It's just clash detection. But I thought it might be interesting to note that it is a feature that has been implemented. Here you can see a mechanical model. Oh, maybe this isn't mechanical. I'll have to check which model this is. Oh, it's two models, I think, mechanical and fire. There we are. And you probably can't build the pipe like this. So that's what this very censored screenshot shows. But again, the clash detection software is actually open source. And that's what made it so fast to write, because I didn't have to write the collision library from scratch. People from the automotive and robotics industry said, why is everybody writing their own clash detection software? Why don't we all collaborate, write a really good open source library, which we can then all use in our individual automotive, manufacturing, and robotics manufacturing fields, respective fields. And that's what they did. They sat down, and I think there are a few big car brands behind it. And they said, let's build this. And so they did. And I guess I just came along one day and I said, hey, look, it's built. Let's just use it for a building instead. And it kind of works out of the box. So that was pretty easy to do. Kobe is another one. Here's a heavily censored spreadsheet just showing a demo out of a very basic file. Kobe, as some of you might be pointing out now, silently in your heads, Kobe was originally designed, well, the main deliverable of Kobe is not a spreadsheet. The main deliverable of Kobe is IFC data. That's why it's a IFC MBD. Unfortunately, many people still do expect to see the Kobe metadata in a spreadsheet format. And so given that, many people don't realize that Kobe is actually very strictly defined. What is and isn't a maintainable asset is defined in the Kobe standard. You can obviously change it if your client disagrees, but at least it's a black and white starting point. It's not some ambiguous, oh, this thing is more maintainable than that. And Kobe defines exactly not only what information you should store as a starting point, again, discuss with your client and figure out what other information is needed for their FM team. But not only do they specify the information, they specify how it should be stored and structured in the IFC file. And very few people actually check their IFC files coming out of proprietary software to whether or not it adheres to the Kobe standard. And if that discipline is not taken, it means that Kobe data produced out of IFC, we're not talking about the spreadsheet here, but produced out of IFC cannot be used verbatim in FM software. And that hinders interoperability simply because we aren't checking for the cleanliness and structure of that data. And you can't really fault us. It's, for many of us in this call, maybe we are not FM data geeks, but it is something we should probably be a little bit more mindful of. So Blender Bim Add-on does come with this additional tool called IFC Kobe, which allows you to take an IFC and will attempt to extract that out into a spreadsheet and will complain very generously to you of anything which is ever so slightly not stored in the right location. I should mention that the conversion is one way. The spreadsheet is seen as a subset of data of the full Kobe requirements, so you can't convert back, but it should be interesting. One thing I should mention is obviously this is also free software, is that all these utilities of things like Kobe conversion or clash detection or BCF management or structural analysis or construction documentation or even the light rendering part, they're all actually built as individual separate utilities. So if you wanted to, you could have your own digital pipeline. You don't need to fire up Blender for everything. Blender can be completely scripted. For example, you can run clash detection in Blender headlessly, automatically, every time somebody submits a new IFC model to your CDE. Or you can have Blender automatically generate a Kobe report out of a Kobe report in a spreadsheet format out of IFCs which are submitted to your CDE, or do a clash detection automatically, and so on and so forth. One way of accessing it is through the Blender interface, but this has been designed in a way to, again, give the user as much freedom as possible to mix and match their own tools. And I won't elaborate on how to do that technically now. This is just an overview, but just wanted to highlight that. This is another feature that Blender Bim has. It's something I call Bim Tester, again, developed as a separate module. And some of you may have used tools like Solibri or I think Simple Bim or something, which lets you audit the data in an IFC file. Basically say, is this parameter filled out? And if it is filled out, does it contain this content? And things like that. Or is this object in this room? Or is this person assigned to this object? And so on and so forth. So this lets you do that, but in an open source way. So rather than having all of your tests being defined by a proprietary software, which I guess will disappear soon, you can test it using open source software in a readable format. So these are all simple English sentences which people can realize, and it's all accompanied with a short paragraph describing the purpose, the business interest, and why you might want to achieve this, the stakeholders in which this achieving this technical exchange requirement makes sense or will benefit, and then what technical strategy you need to implement in order to achieve it. So this starts that dialogue between the technical and the non-technical stakeholders, between why it's so important to have clean data. You know, why do we care that a wall is called a wall? Well, it's so that you can identify classes. What does that mean? It's so that maintainable assets are automatically classified as maintainable assets for FM deliverables. It's so that pipes and walls have a higher priority than pipes and furniture during collision detection. There's a hierarchy here, and all that can be automated so long as your original data is structured and clean. I think I might accelerate a bit here. I'm running out of time. This interesting little example was not done by me, but this person used Blender and the Blender Bim Add-on to take an IFC file, and this IFC file was produced by, I think, a compactor machine when constructing a highway, and he had written a script in Blender to process the points provided by the compactor machine and provide a visual representation of that, which could then be included in BIM programs, I guess, for coordination or something like that. And this was a fully automated process which was done every day, and that got me really excited, especially because this was just after, I think, a few weeks of developing Blender Bim. This was a very, very early days before many things even had a button that you could press. And this shows that, firstly, it shows that Blender has very, very flexible scripting capabilities and can also be fully automated without having to come up with, virtual servers that spin up an instance of the program and run a script and close it down and all that type of complexity. It's very easy to automate, but also for very interesting use cases, you can see here. Anyway, so that was the sort of intro of Blender Bim Add-on and kind of one of the things it's starting to push into. But Blender Bim is just one of many. And Blender is just one of a huge community of open source that is, let's just say, underrepresented in the AEC industry. And so an initiative I've taken is to start something called the OS Arch community. And I think we now have something like 300 forum members or so, 330. And it's a collection of individuals who believe that we can use free software and increase transparency due to the open data approach, and a more ethical approach due to not tying our businesses to the whims of other businesses, not placing money first, but putting purpose first, not and really thinking, what can we do to redesign our workflows for how we believe the built environment should be like. And Blender is one part of a big picture. Like, you might have heard of Blender, you might have heard of OpenStreetMaps, but that's just a few. And we've started up a wiki, and we started collecting a directory of free software. And there's 100. I think we're near to or have just exceeded 100 pieces of software on this list that is relevant to the AEC industry. Everything from modeling to rendering to structural simulation to CFD simulation, even simulation of explosives. I guess you might need that on defense jobs, and so on, is all listed in here. And I would probably assume that, like myself, you can, when I first started this, I could probably name 10 or 20, and some of us even less than that. But there's actually a growing list of open source initiatives in the AEC industry. Most recently, I saw one for visualizing real-time IoT sensors in building maintenance. And so it's a fast-growing field. I highly recommend you guys, if you want to get involved a bit more, look at OSArch. It's osarch.org. I'll put links at the end. And just to show you that Blender is just one small drop in the ocean that has previously been hidden from the AEC industry, I'll flick through some of the other examples. We have Freecad, which is how I actually started with writing some things to do with BIM. Freecad offers parametric solid modeling, similar to CATIA. We have, I guess, more computational design tools like Tissue. So that's some parametrically generated form, I guess, if that's what you want, to build buildings that look like an octopus. But if that's not your thing and you're a bit more down to earth, this is OpenStreetMaps again. So on the left, we see Google Maps. And I guess that's Google Maps for you, right? This is some place, I forget where this actually is, but it's clearly not a major city in a first world country. But we understand why that's not top of the priority list on the people behind Google Maps, but it is top of the priority list of the local community. So I think this was done by 70 people. 70 people sat down for one evening, and in one evening mapped out the entire city, and of a population of, I think, 120,000 people, for the purposes of making it easy for first responders and humanitarian aid people to respond in the case of natural disasters or medical supplies and so on and so forth. And this shows the shift in the way that our tools are designed when you put purpose first. If that's not quite your thing either, and you want to analyze it, QGIS is an incredibly powerful tool. Some of you might have used ArcGIS before. QGIS is an excellent alternative to that. Cloud Compare, again, extremely powerful point cloud analysis software for those who are doing laser scanning and on-site verification. And of course, we're starting to see a crop of, I guess, web-based CDEs and collaboration and project management platforms, if that's your thing. So here we have Open Project, which I think is also participating in the upcoming Open CDE standard. And it might make us realize, we don't actually need to stick to just one thing like the AConnexes of the world and so on. There may be alternatives out there, and we should start judging things based on their merit and how they help they help us achieve our respective workflows. And of course, governments are also pushing it. This is Australian-centric. I'm not too familiar with the Canadian government, but the New South Wales, which is a state in Australia, has developed their digital twin platform on open source technologies, and made all the, and being open source and free software, obviously you can dig into it and develop your own digital twin. So it's really interesting. You can see there it's also powered by Cesium, which is again an open source initiative. So governments have at least a lot of governments have seen the importance of open data and the fact that our built environment is actually a public good. And for many governments, a lot of GIS data is open data. And I guess it makes us start to say, well, okay, if I can download the land, why can't I download it at the building level? That's what impacts me at a human scale. And maybe that will be the future. Maybe in the future we will be having open data repositories of downloadable buildings at the urban scale, so that at the very beginning everybody has access to analyzing our built environment in a little bit more granularity. And this makes us question, what do you want to do with your built environment? Again, it's not about the software. The software is a side effect. The first thing that comes first is the culture of freedom. What do you want to achieve? Is it to have a fully interconnected BIM model with every discipline? Is it to have a public data so that the public can track where all our environmental resources are being spent in the public domain? Do you want more transparency in the construction process? Do you want more accountability? Is it more sustainability? What is the purpose here that you're going here? And are the tools that we have right now the right tools we need to achieve those purposes? Or are they simply tools that tell us we need to build more buildings more efficiently? Because the last time I checked, I don't know about you guys, but maybe that's not what the world needs. Maybe the world doesn't need more buildings faster. Maybe the world needs better buildings. And I don't think any one of us knows what that better building is like, but I think all of us know that we need to work together a bit more, because we don't have all the answers. And in order to do that, we need collaboration. We need things like open source. We need the freedom to build our own pipelines. We need the open data standards to collaborate with one another. So I hope I'll leave you on that note, and hope you've seen a little bit on what else is available. Here are some links. And thank you very much.